Assalamualaikum warahmatullahi wabarakatuh and good morning everyone. So today we continue our lesson on the introduction to scientific programming chapter 4, which is related to the control flow. Okay, so first thing first, we'll take a look at the objective for this chapter. Okay, so the first objective for this chapter is to be able to write a decision algorithm into a program using if, else if, and switch case statement. So at the end of this chapter, you are expected to be able to write a decision algorithm by using if, else if, and also switch case statement. Okay, the second objective is to know the difference between the if, else if, and switch case statement, okay, and which situation is the best for each of the statement. So towards this chapter, you will be present with many of the example of if, else, and switch case. Okay, so you can know what are the differences and which situation is suited for which problem. Okay, and the third objective is to be able to convert the if, else, if statement into logical vector decision method wherever possible. Okay, so later on you will know how to convert the if, else, if statement into a logical vector decision method, because the logical vector decision method is faster than if, else, if statement. And the fourth one is to be able to write a loop algorithm into a program using for and while statements. And the fifth one is to know the difference between the for and while statements and which situation is the best for each of the statement. Okay, for objective 4 and 5, you will know how to design for and while loop statement and how you want to use it and which one is the best for which situations. And the objective number C is to be able to convert the for statement into array operation wherever possible. So at the end of this chapter, you must be able to convert the for statement into array operations. Okay? Okay, so before we proceed with this chapter, let's recap the operations of the variable inside scientific programming. Okay, first, as usual, we have a statement. So in statement, the first part is the assignment. So we must assign a variable to some numbers or some expression. Either it is arithmetic, which is related to the number, or either it is Boolean, which is related to the logical input with if, true and false statement. Okay, 0 or 1. And then the repetition statement, which is while and for loop. Okay, so this is the one that we are learning in this chapter. And the third one is a decision. So decision is to execute statement if, else, if, and also the switch case. Okay, so this decision, it is used to come out with a decision of a situation. Okay, so later on when you are given a problem, you will have some decision, which is the answer that you will produce. Okay, so in order for you to get that answer, you must have a specific condition. Where does the answer comes from? What is the situation when the answer is executed? Okay, and then of course you will have a function, which is a set of statement, and lastly you will have a command. All right, so let's start with the control flow. So what is the types of control flow? So control flow can be divided into two, which the first one is the conditional, and the second one is the loop control. So the conditional control flow, it is related to a decision statement. And in this control flow, okay, in this conditional control flow, it tells the computer to pick and run one of several sets of statements based on certain conditions. Okay, so inside conditional control flow, we have lots of alternatives. Okay, and then this conditional statement, it will tell a computer to only pick one. Okay, pick one condition to run instead of run all of those conditions. Okay, all right, so the second one is the loop control. So loop control, it is actually related to the repetition statement. So if you wanted to repeat the statement until one state, you need to use loop control. So in loop control, it tells the computer to repeat certain set of statements for n number of repetition or while some condition is fulfilled. So it will keep the same process again and again and again and again until n number of repetition or until some condition has been fulfilled. Okay. So other than the above, repetition controls such as skip and early exits from the repetition are also possible. Okay. For example, if you are inside the loop, but at one time you wanted to skip and you wanted to exit, you can do that. Okay. All right. So that are the differences between conditional and loop control. So in loop control, it has repetition statement, but in conditional control flow, it tells the computer to only run one condition, okay, based on a certain condition. All right. Okay. So before we proceed with this chapter, I will show you how you wanted to create a MATLAB script inside MATLAB. Okay, so scripts are the simplest type of program file. Okay, so in this MATLAB program, we are producing some scripts. Okay, so the scripts are the simplest type of program file. So inside the script, you will be able to code your program. Okay, and then script has no input or output arguments, and they are useful for automating a series of MATLAB commands such as computations that you have to perform repeatedly from the command line or series of commands you have to reference. Okay. Alright, so in this chapter, all examples are written as MATLAB scripts since we now need a series of commands to work with the control flow. Okay, so in this chapter, all of those examples that you are using, so you need to make it into script, not as a command. Alright, so next is to create and run a script. So how you want it to create and how you want it to run a script. Okay, clicking the new script icon will open a new script editor and write the code inside the editor and save it as a .m file. And then run the code by either typing the file name on the command window or click the run icon on the editor window. Okay, so this is your MATLAB interface. So you can just go to the home and then click add new script. And if you want to run your script, you can press run. Okay, so I will show you how to create a script. Okay, previously, this is the command window that you have. Okay, so for example, if you wanted to initialize a variable a equals to 5, so it will automatically give the output of a equals to 5 here. But right now, when we wanted to create a conditional and looping conditions, you need to create a series of codes. So you cannot run in each and every command that you are typing. Okay, when you are typing each line, so it will execute. No, you are not doing that. But right now you are doing a script. You need to do a script. So to do that, you just need to go to the new script. Okay, and then this editor will be appeared. Okay, so right now you can initialize a equals to 5 and b equals to 6. Okay, for example. All right. Okay, and then first thing first, that what you need to do when you are creating a script is you need to save it, because when you are not saving it, you are unable to run the codes. Okay, and then for example, I wanted to save at the desktop and I wanted to rename it as test. Okay, and then I click save. Okay, so right now I can run my code. Okay, for example, I clear inside the command window first, and then I click run. Okay, you need to change your folder. Alright, so right now it will indicate that you are running the test.m by indicate here test. Okay, and then it will execute the variable a equals to 5 and variable b equals to 6. Alright, but you can also run your coding part by part. Okay, so in order for you to run your coding part by part, you need to put a percentage, double percentage. You need to put 2% symbols inside your coding, okay, between the codes that you wanted to run. Okay, for example, you wanted to run a equals to 5 first, so let me clear up the command window. Okay, you see here this is empty, and then you click at a equals to 5 area, which is it will divide into two different area. Okay, the area upper the symbol double percentage and the area below the symbol double percentage. Okay, and then when you click at the upper part, and you can click run section or run in advance. When you click run in advance, it will only run a equals to 5. Okay, and then when you click run in advance again, it will execute the second coding, which is b equals to 6. Okay, and you can also just click run, so it will execute all parts of your coding. Okay, so this is how you can create this MATLAB script and how you can run your MATLAB script by using overall running or by using parts by parts. Okay, so let's continue to our lesson. Okay, so the first part of this chapter is about conditional control for scientific programming. So how you wanted to create and how you wanted to design conditional program. All right, so the first part of the conditional program, or the first type of conditional program, is if else if else. Okay, so this condition will execute statement if condition is true. For example, if condition 1 is true, it will execute statements. Okay, or if condition 2 is true, it will execute statements. But if condition 1 and condition 2 is false, it will create this statement and then it will automatically end. Okay, so the condition is normally expressed as Boolean expression. Okay, so if condition is expressed as arithmetic expression, condition is true when the value is non-zero. Okay, so usually this true and false condition, if the if condition is true, it means that the condition 1 will become 1, and if condition 1 is false, condition 1 will become 0. Okay, so it will convert it into Boolean expression. Okay, and the second one is the switch case otherwise. Okay, so it will execute statement based on the value of a variable. Okay, for example, switch n, so it will get the input of n. What is the value of n? If the value of n equals to value 1, it will create this statement, it will run this statement. But if the value of n equals to value 2, it will create and it will run this statement. Otherwise, if the value of n is not equals to value 1 or value 2, it will execute the otherwise statement. Okay, so in switch case, variable n is normally expressed as arithmetic expression. Okay, so variable n is actually a number. Okay, so case value must be scalar or string, so it can be depending on your program. Okay, to compare against multiple value, you need to use cell array. So if you wanted to compare the values by using multiple values, you need to use array. Okay, all right, so let's go to some example of single if else. Okay, so the first example, so you see here in this example, we are initializing the value of x equals to 2. So if x is less than 0, it will display negative, and if x is not less than 0, it will display non-negative. Okay, so when we initialize x is equals to 2, so does 2 is less than 0? No, right? So it will not display the negative, so it will display non-negative because 2 is not less than 0, because this first condition is not being fulfilled. All right, so this code will display non-neg at the command window. Try change the value as x equals to negative 2. So when you change the value of x equals to negative 2, so negative 2 is less than 0. Therefore, it will execute this statement. So it will display neg, which indicates negative. All right. So in the second example, if 79 display true, else display false, and so this code will display true at the command window. So try other values including 0 and negative values. Okay, so it means that if 79, so any other number rather than 0, it will display true, because the if and else statement, it will convert the number into Boolean expression. So as I've been told to you before, to convert from number to Boolean expression, if any number other than 0, it will be automatically convert into 1. And if the number is equals to 0, it will convert it into 0 in Boolean. So if 79 is 79 in Boolean, it is equals to 1, so it will automatically display the true. But if you replace 79 with a 0, it will display false, because this condition has not been fulfilled. All right. So the next example is about multiple condition with single if. So let's take a look at example number 3. Okay, for quadratic equations of ax squared plus bx plus c equals to 0, it has equal roots given by negative b over 2a provided that b squared minus 4ac and a is not equals to 0. Okay, so for this question, as you can see here, for quadratic equation of ax squared plus bx plus c equals to 0, it has equal roots, which is given by these equations. So in order for you to get the root, you need to use equation of negative b over 2a, provided that b squared minus 4ac is equals to 0. So this is the first condition that you have, and also a must not equals to 0. So this is the second condition that you need to have in order for you to has a equal roots. So in order for your situation to has equal roots, okay? So this is formula to calculate the equal roots. All right. So below is the MATLAB code to compute the equal roots. Okay. So the first one is a equals to input. Okay, input. You need to initiate a string, input a value. Okay. B equals to input in terms of input b value, and c is equals to input in terms of your function is input c values. Okay, so when you execute this statement, so it will detect the input that you give, okay, and it will initiate it as a. Okay, all right. So next is d. So d is equals to b squared minus 4ac. Okay, b squared minus 4ac. All right. So this is our if condition. Okay, so what are the condition that indicates the roots are equal? So this is the two condition. So the first condition is when b squared minus 4ac equals to 0 and when a is not equals to 0. So when those two conditions are fulfilled, so it means that it has equal roots. Okay, so in order for you to calculate equal roots, you need to use this formula. All right. Okay, so this is the if statement. So if d is equals to 0, so what is d? D is equals to b squared minus 4ac. Okay, if b squared minus 4ac equals to 0 and a is not equals to 0, so it will execute this formula, okay, which is equals to this formula to calculate the equal roots. Okay, but if these two condition is not fulfilled, so it will display different root. All right. Okay. So next example is multiple condition using else if. Okay, so this is example number 4. So actually you can just copy and paste the codes that are given in all of the example in this chapter, and you can try it by yourself. Okay. So example number 4. Other than equal roots, there are two other types of roots for the quadratic equations, provided that a is not equals to 0. The non-equal roots and complex roots. Okay, so other than equal roots, the condition where a is not equals to 0, there are other types of roots that will be appeared, which is the non-equal roots and also the complex roots. So below is the MATLAB code to compute only for the real roots. Okay, so last time we initialized d as b squared minus 4ac. Okay, so if d is equals to 0, so this is the previous condition that we have in example number 3. So if b squared minus 4ac equals to 0 and a is not equals to 0, x1 is equals to negative b over 2 times a. So this is the equation which is used to calculate the equal roots. Okay, and then x2 will be equals to x1. Okay, so x2 is actually the output for this function or for this conditional condition. Okay, conditional statement. Okay, so else if d is greater than 0 and at the same time a is not equals to 0, so x1 equals to negative b plus square root d divided by 2a, and x2 will become negative b square root d divided by 2a. Okay, so this example will show you the real roots. Okay, And then else if those two conditions is not being fulfilled, it will display complex root. Okay, so I think you can revise back to your engineering mathematics. Okay, what are the equal roots, non-equal roots, and also complex root? So then you can relate it with this example. Okay, so this code use else if since there are more than two conditions. Okay, so if you have more than two conditions, you need to use else if. But if you only have two conditions, you need to use if and also else. Okay, you don't have to use else if. Okay, so right now we have three different conditions, so you need to use if, else if, and also else. And last part that you need to use is and to indicate the end of your if condition statement. Okay, so next example is about nested if. What is nested if? Okay, let's take a look at the example number 5. Okay, to complete the problem, nested if is used where the first if is dedicated to variable A, while the second if is for the variable D. Thus, now for the root when A is equals to 0 is now being computed. Okay, so nested if is actually if statement inside the if statement. Okay, you can see here. So as usual, D we initialize it as b square minus 4ac. Okay, so if A is not equals to 0, and then we have another if here. Okay, if A is not equals to 0, if D equals to 0, so it will execute this statement. Else if D is greater than 0, it will execute this statement. Okay, and else it will display complex root. Okay, so this example is similar to the example number 4. But right now we have nested if, which is if statement inside a bigger if statement. So if inside if, we call it nested if. Okay, all right, and then we have else x1 equals to negative c over b. So and so in the big if statement, it only has two conditions. So this is the first condition, okay, the first big condition, and this is the second condition. That's all. So which is why it doesn't use any else if. Okay, but inside the nested if, okay, if inside if, okay, it has three statements, 1, 2, 3. That's why it needs to use an else if statement. If, else if, else, and you need to close it with and. Okay, to close the nested if statement. Okay, and then the bigger if statement, you need to also end it with and. Okay, so when A is equals to 0, the quadratic equations become linear equations. Thus, only one root available and computed as x1 in the outer else. Okay, so next is switch case. So what is the example of switch case and how you wanted to create a switch case? So let's take a look at the example. So else if, okay, is the conditional case which is great for variable condition that results into a boolean, but switch case is great for fixed data values. So for example, the else if condition is great if you have the condition between a value. For example, if 1 until 5, what will happen? If 2 until 3, what will happen? Okay, so else if in great in that situation. But switch is great in a situation where, for example, if A equals to 5, what will happen? And if B equals to 6, what will happen? So it doesn't have any other range. Okay, so if the number is static or the number is fixed, it is recommended for you to use switch. But if you have a set of range of values in order to run a situation, it is advised for you to use else if. All right, so the example number 6. Okay, so first we need to initialize the input. Okay, what is the input that we wanted to give? Okay, so n equals to input, in the bracket enter a number. Okay, and then you need to close the what do you call the apostrophe, and then close the bracket. Okay, and then you will start switch, the switch case. Okay, switch n is the input that you will give. Okay, so case -1, it means that if n is equals to -1, it will display -1. So if n is equals to 0, it will display 0. So if n is equals to 1, it will display +1. Okay, otherwise it will display other value. Okay, so if the number is fixed, so if the number is not changed, so if your condition is not between some numbers variables, okay, so it is great for you to use switch. Okay, so every case is referring to a given fixed value. So in this example, -1, 0, and 1. Okay, so it will the output will become enter a number, okay, and then you will enter a number 1. So the output will become +1 because it will go to the case 1, because n right now is equals to 1 because you give number 1 to the input. Okay, all right, next is design using logical. So how you want it to design using logical? So instead of if and switch statement, logical approach is another method to execute decision statement. So instead of you are using if and switch condition, you can also use logical approach. But how you want it to use it? So let's take a look. Okay, so it is useful in avoiding the if and switch statement when involving mathematical equations, which is common in scientific programming. So this design using logical, it is usually used inside mathematical expression or equations. Okay, so the advantage of design using logical, they are almost always faster than if and switch methods, and it can be easier to read since the expression can be written very close to the mathematical equation form. Okay, so later on you can see the difference between if and switch if and switch condition approach and also logical approach. Okay, so what are the differences and how you want it to design and when you want it to use those kind of condition. So in logical approach, condition in if and switch statement is replaced by a logical multiplier array. So inside a logical approach, you don't have if, you don't have switch. You only have a logical multiplier array. Okay, so let's take a look at the example. So example 7. So a simple version on how to calculate the income tax could be based on the following table. Okay, so this example, it is used to show you how you want to calculate the income tax. Okay, so if your income is $10,000 or less, to calculate your payable tax, it is actually 10% of taxable income, 10% of your income. Okay, so if your income is between $10,000 and $20,000, so the equation is like $1,000 plus 20% of your taxable income. Okay, and if your taxable income is more than $20,000, so the equation is like $3,000 plus 50% of your taxable income. Okay, so this is the example. So if you wanted to find the tax payable on a taxable income of $30,000, so for example, if your taxable income is equals to $30,000, so how you want to calculate and which equation or which formula that you need? So of course you need to use this equation, which is more than $20,000 because your taxable income is $30,000, which is greater than to 20,000. So you need to use this formula. Okay, so to use this formula, you need to make it like 3,000 plus 0.5, so which is equals to 50%. Okay, minus multiplied by 30,000 ringgit, okay, of amount by which taxable income exceed 20,000. So we need to find the difference. Okay, 30,000 minus 20,000 equals to 10,000. So 3,000 plus 0.5 multiplied by 10,000 ringgit. Okay, it will become 8,000 ringgit. Okay, so your tax payable, you need to pay for $8,000. Okay, your tax. Okay, so below is how the tax payable calculation is solved using else if. Okay, so this is how the example number 7 is solved by using else if. Okay, so first and foremost, you need to use the input functions. Okay, so INC is the income tax, what do you call it? Taxable income. Okay, taxable income equals to input in the bracket input and income, which is an array. Which is a string that you wanted to display. Okay, input and income, and then you need to input the income. Okay, so if income is less or equals than 10,000 ringgit, so you are using the formula of 0.1, which is 10% multiplied by the income. Okay, else if your income is less or equals to $20,000, So your tax that you need to pay is like $1,000 plus 0.2, which is 20%, multiplied by the difference between your income and $10,000. And else, okay, tax is equals to, if your tax, if your income is more than $30,000, $20,000, you need to use like 3,000 plus 0.5 multiplied by income minus $20,000. Okay, and you need to end your statement. Okay, and then lastly, you need to display the tax payable equals to, and then number 2 string tax. So you need to use the conversion from number to string, okay, in order for you to display the value here. Okay, so it will display like input and income. So you need to give the input of your income, which is $30,000, and it will calculate to you. So for if else condition, you need to put if, else if, else, and and. So right now you need to use else if because you have 3 different conditions. Okay, all right. So what if you wanted to use logical vector, and how you wanted to use it? Okay, to convert the else if method to logical methods, the conditions are multiplied with their respective formulas. Then the result of all condition multiplication are added to get the final answer. Okay, below is the coding structure. Okay, for example, for variable 1, okay, formula number 1 multiplied by condition 1. Formula number 2 is multiplied by condition number 2. So condition number 2 is the logical vector. Okay, until variable number n is the formula n multiplied by condition n. So condition, it is like true and false. So if it is true, it will get the what they call the formula. Okay, but if it is false, it will become 0. So the formula will become invalid. So the formula will become 0. And at the end of the coding structure, you need to add all of the for the variable. Okay, variable, which is the output, equals to var1 var2 plus var n. Okay, so when condition, for example, when the condition 1 is fulfilled, okay, so condition 1 will become 1 and var1 will become formula 1, and condition 2 will not be fulfilled because condition 1 is already fulfilled, so it will become 0, and condition n will also become 0. So the final answer is equals to var var1 because condition 1 is fulfilled. Okay, so to get a clearer perspective, so let's take a look at the the example and how we want to compare it. Okay, so how it works: only one condition will be true at one time. Okay, as I've said before, only one condition is true. Thus, the addition at the last line will result the output of the formula with the true condition, because the other condition will become 0 and the other var will become 0. So it will choose only the selected bar which has the true condition. Okay, so example number 8 is actually based on example number 7. So below is the mathematical equation of the tax payable calculation for the MATLAB code using the logical vector methods. So I have been converted the table in example 7 into mathematical equations. So if for your income which is less or equals to 10,000, you need to use this formula. So if your income is greater than 10,000 and less and equals to 20,000, you need to use these equations. And for your income is greater than 20,000, you need to use this formula. Okay, so you already have different formula for different type of condition. So how you wanted to create a logical vector? So this is the MATLAB codes. Okay, so as usual, you need to get your input. So INC, which is your income, equals to input function. So input in bracket input and income. Okay, as usual, you need to put this input condition, and then so tax 1 is equals to var1 in the previous syntax that I've shown you. So var1 equals to 0.1 multiplied by income. Tax 2 equals to 1000 plus 0.2 multiplied by income minus 10,000. Tax 3 equals to this one, 3000 plus 0.5 multiplied by income minus 20,000. But we have an additional element here, which is the logical vector. Okay, so it will multiply by income less and equals to $10,000. Okay, because the condition is valid only for income of less and equals to $10,000. Similar to this one, income multiplied by income greater than $10,000 and income less or equals to $20,000, and multiplied by income which is greater than $20,000. And lastly, we need to add all of those tags. Okay, it's like add all of those var by comparing the syntax that I've shown to you before. So tags equals to tax1, tax2, and tax3, and then you can display tax payable equals to, as usual, number to string to tax. Okay. All right. So when you input an income of $30,000, so what will happen? Okay. So when you give your input, which is $30,000, tax1 will become 0.1 multiplied by $30,000, and it will multiply by 0 because the income that you have been input is not less or equals to $10,000. So tax1 will become 0. And tax2 will also become 0 because it doesn't fulfill this condition. So this condition only become 1 when the value that you give is between 10,000 to 20,000. So right now we are inputting like $30,000, so it will not valid. So it will become 0, and finally tax2 will become 0. And lastly, this condition, income is greater than $20,000, it will become 1 because you are inputting $30,000. So it fulfills this statement. Okay, so it will become 1, and this formula will be executed. Okay, so tax3 will become tax3 will calculate all of the taxable income that you need to pay. Okay, so lastly, tax equals to 0 plus 0 plus tax3. Okay, so tax will be equals to tax3 because $30,000 fulfill the tax3 condition. Okay, so this is how you can design your conditional decision by using a logical vector. So from this example, I'm sure that you already know and you already sure which type of condition or which type of conditional operator that you need to use. Either it is if-else, or either it is switch, or either it is logical vector. So you need to know how to choose those variables. Okay, for example, if you have it's like a statement which is not related to some mathematical expression, you need to use if-else. So it is recommended for you to use if-else if your condition has some, your variable has some range. Okay, but if your variable is static or it is not moving, so you need to use switch statement. But if you are using mathematical expression, okay, you need to use the logical vector because it is simpler and it is faster. All right, so I think that's all for today's class, and for next week we will continue to the last part of chapter 4, which is related to the loop control. Okay, so if you have any question, you can ask me in the WhatsApp group. Okay, so, and I will answer your questions. All right, so that's all for today's class. Thank you.